Hey everyone, thank you for joining us today. My name is Inbar Caesar-Kobrinsky, and I'm joined here today by Tarek Daoud. We are both program managers on the Identity and Network Access Division at Microsoft. Today, we are here to talk with you about how you can raise the bar on multi-factor authentication, MFA in short, by using phishing-resistant authentication method. Before we dive into the details, I want to share with you some statistics. The first one is that over the last 2 years, we have seen an increase of over 300% in strong authentication adoption. When I'm saying strong authentication, I mean user using a password plus another factor, such as a code that they get through a text message or push notification, or that they're using our passwordless authentication method, FIDO2, Windows Hello for Business, and phone signing with the Authenticator app. We're also seeing an increase in strong authentication adoption for administrators. So we are seeing an increase from 8.2% to a little bit over 30%. We still have a long way to go with our administrators. And then finally, I bet you already heard these statistics from us before. Multi-factor authentication protects against 99.9% of the identity attack in the general population. So really, we should all be thinking about how we are protecting our own accounts, whether they're personal or work accounts. As strong authentication adoption is increasing, attackers are becoming more sophisticated. And the traditional MFA methods are prone to some of the known vulnerabilities, such as social engineering, account takeover, device theft, and our focus for today, phishing. So what is phishing? Let's talk about that for a second. Phishing is when a user provides a secret, for example, a password, to a third party who can then reuse it and sign in as the user. So let's take an example. Attackers set up a website that looks very similar to the user's identity provider, IDP in short, site that the user is using on a regular basis. The attacker is luring the user into going into this website and typing their password. The attacker then uses this password and replay it against the user's real, true identity provider. If the user happened to be protected by multi-factor authentication, let's say they got an SMS code from their true identity provider, the attacker then asks the user to type the code in their fake website, and then similarly replay it against the user's identity provider. That way, the attacker, signs in as the user. As those types of attack becoming more and more popular, you will start hearing more and more about phishing-resistant authentication methods. We're also seeing some of the US government agencies starting to mandate this to better protect government employees. So to be clear, MFA is essential. I'm not talking about whether you should be using multi-factor authentication, but which method you should be using. So to understand how it works behind the scene, let me invite my colleague Tarek to take you under the hood.
Thank you very much, Inbar. Hello, everyone. My name is Tarek Daoud, and I am a program manager and teammate of Inbar's in the Identity and Network Access Division. I'm here today to talk to you about kind of how phishing-resistant credentials are phishing-resistant by design and the technology that goes underneath to make some of these guarantees. Understanding this helps you kind of pitch it to your leadership, pitch it to your end user, especially when they understand also how much it protects privacy and so forth, as we will demonstrate. So let's get right into it. The technology that Microsoft and a lot of other vendors are using is called FIDO2 technology. The FIDO Alliance is an alliance of these large organizations who are trying to strengthen the available authentication options for end users, consumers in general. They're not just part of one company or one direction. And so we're going to go a little bit over the technology in detail about how it works. And we'll start with the typical two components of our authentication, which is the identity provider and the user. So we'll draw the identity provider over here, classically called IDP for short. And we will draw our end user over here. The end user in this case will be using a client to authenticate to the identity provider. In the modern protocols, this client is usually the browser, and so we will write here client/browser. There's an important implication here in that a lot of these new standards for phishing-resistant credentials require modernization of protocols, And so some of the legacy protocols that don't support browsers, that don't work on web interfaces will not be inherently safe. And this puts an onus on you to move to more modern protocols. But for now, let's focus on the authentication flow. FIDO standard, and I'm going to write the name here so folks can also go reference it. This is a FIDO 2.0 flow. It's reliant on two standards. The first standard is something called WebAuthn, and we're going to write the name here because it is the standard that defines what happens between the identity provider and the user's client, the browser. What kind of handshakes and calls back and forth that are supposed to happen, that can happen. For those of you who are nerds into standards and that kind of thing, WebAuthn is actually part of the W3C working group. So it's part of the standard, just like HTTP. It's part of the standards for web calls and web requests and web responses and so on. The other part of the FIDO protocol or the FIDO standard that matters as a standard, as a protocol, is something called CTAP, and we're going to write it here. CTAP. In the case of FIDO 2.0, it is CTAP 2.0, 2 plus. CTAP is short for Client to Authenticator protocol. It is a protocol that defines the interaction between the user's browser and the user's security key, whatever that actually does, the credential that you're going to actually give the end user. So now we're going to talk about what actually happens when a user is trying to register a credential with an identity provider. Like basically you're signing up to a website. Traditionally you put in, my username is Tariq@contoso.com and my password. Now instead of a password, we're going to give you a FIDO credential. FIDO credentials come in two forms. One form is what we describe as a platform authenticator. A platform authenticator means it's built into the actual computer you're using. An example of that is Windows Hello for Business. Windows Hello for Business is a platform authenticator, meaning that it's built into the OS, the device that the client is actually operating on. The other example of that is an external security key, a FIDO key, just like this one. In this case, the user actually in their hand, they're having some kind of external security key that they plug into the computer's USB port, NFC, Bluetooth. There are all kinds of different form factors that we integrate with. And the authenticator has, for example, the ability to read the fingerprint of the user, has the ability to have a PIN as a second factor. When you finish a FIDO authentication, you've proven that there's something you have, the key in your hand, and you've proven something you know or something you are by either touching and reading a fingerprint or typing in a PIN. So it's a strong factor. It's two factors at the same time. So it's a password and MFA at the same time by simply completing a FIDO 2.0 authentication. That's the principle we're going to operate on. So let's see how these things work under the hood to make a phishing resistant authentication. So we're going to, for this step, let's use a different color. And we're going to render now the storage. What's stored, whether inside the Windows Hello for Business TPM chip or inside the external key. We're going to continue with the FIDO key example. And so we're not going to make this picture any harder. We're going to actually render, let's say, the storage of this FIDO key. What's under the hood here? So if you allow me, I'm going to draw a little cylinder that represents the storage of this key. And over here, I'm going to draw a bit of a cylinder that represents the storage of the identity provider. Why am I doing that? Because I want to help you also understand how FIDO eventually addresses the core weaknesses of passwords. Passwords have three really bad weaknesses. One is they're picked by the user. That's the worst thing about password, right? So if I know how you pick your passwords, I can guess your password in a lot of other places. Your sister has a really good handle on your password. Your cousin, your mother, your wife, your spouse, your significant other, and so forth. And so generally, that's one of the biggest weaknesses of passwords. The second one is that it travels transparently over the internet, over the wire, and so a bad guy sitting in the middle can see it and replay it back. That's the second one. And then the third one is that if I steal it from the identity provider, if I somehow break into Microsoft, hack into the identity provider and steal, the passwords.txt file over there, that's a big compromise for the end user as well. And many of you, I'm sure, have received that famous apology email from some website or another that says, oh, sorry, our credentials were stolen. Here is a privacy insurance thingy for you in case you get compromised because of that. And so the FIDO2 approach is trying to address all of these. So let's start with the registration flow. So here I am, user Tariq, and I am going to actually walk over to Azure Active Directory or Outlook.com. We have this both in the consumer space and in the enterprise space. And I'm going to try to register for an account. So let's talk about the registration flow. We're going to use blue here to render the registration flow. The user comes to the site, visits the site as a traditional web request. Hit portal.office.com, portal.azure.com in a registration flow. What's going to happen is the identity provider is going to send a WebAuthn request that says, I'd like to initiate a registration, and it's going to pass the identity that the user is trying to register with, the UPN, the email that you provided to say, hey, I'm going to register as Tariq, and it's going to send with it what we call a nonce, or some people call N1s, a unique number that is generated just for this transaction that the identity provider knows about. So in memory here, identity provider remembers that it sent nonce 1 in this request. What happens under the hood is the client now, due to WebAuthn, all browsers, so Firefox, Chrome, Edge, Safari, they all understand WebAuthn now. When they see this request, they understand what to do. They will pop up a request to the end user that says, hey, do you agree to registering a key with this site? End user consent is always paramount. The user will say yes. At that point, they will say, please insert your security key. A prompt will say, please insert your security key. Again, there's a case of Windows Hello for Business in which it will actually try to satisfy the request right away itself, but we'll stick with the external key case just because it helps you understand the flow better. And so in this case, the request will say, please insert your security key. The end user will plug in the key. We will request that the user does an attestation, meaning do the second gesture. Don't just plug in the key, but also touch the fingerprint reader or put in your PIN. The user will provide that, and at that point, the site is now ready to register. So what is going to happen when it's ready to register? This key is going to register in its storage here. We're going to put a few columns, a few pieces of information. The first thing is it's going to register the site. How does it know what the site is? It doesn't ask the user. It actually knows from HTTPS, because this request was made by HTTPS. FIDO2 does not operate on HTTP regular. So there's no way for a bad guy to spoof what their website is. So in this case, let's say this is a normal register, it's not a bad guy. So in this case, it's going to say, oh, this is login.microsoft.com. This is the website that's trying to create an identity in my key. The second thing it's going to register is the ID. So it's going to say, this is Tariq. He created an identity in that website called Tariq. The third thing it's going to do is going to generate a private key. PRIV. It's going to generate a complicated mathematical private key, a secret. This is the innovation that's happened over the last 5 years that wasn't there 10, 20 years ago when people were doing smart cards. Is that now these tiny little pieces of hardware, this very little small device is mathematically sophisticated enough that it can generate private keys that are very complex. So it's going to generate a private key and keep it stored on the device. It's going to generate a matching public key for that private key. It's then going to take the nonce that was sent in this step. The nonce is going to be passed to the key as part of the registration. The key will take the private key, sign the nonce with it, and then on the response, and I'm going to use a different color for the response, on the response back to the browser, it's going to pass the public key and the nonce signed. So the nonce is going to be signed with the private key. These two responses are now going to be sent back to the identity provider, but the browser is going to take them as is and say, okay, in response to this registration attempt, the key has done the following. It has given me this public key, and it has given me the signed nonce. Now, and we'll call signed nonce 1. What does Azure AD or the identity provider in this case do? Is we take the signed nonce and the public key, and we check the signature. Yes, this nonce came from this public key. And then we check that this nonce is the same as the nonce we sent originally, not some other guy replaying something back at us. If these two checks match, then we create in our identity, in our table, for this tenant or for this user, we will say, okay, Tariq registered with our system, and his credential in Azure Active Directory is the public key. So this is the happy flow of a sign-in request by a registration request by an end user. Now let's play this back in terms of a sign-in request subsequently. So as an end user now, I'm going to come in the next day, tomorrow, the day after, and now I want to use my FIDO key to sign in. What is Azure D going to do? It's going to come back with a new WebAuthn request. In this case, it's a sign-in request, so it's not going to say, I want to register. It's actually going to say, this user is trying to sign in, and it's going to send a new nonce, which is going to send nonce2. What the key will do is, first of all, based on the IDP, which identity provider is this? It's not up for the claimant to claim. It's actually up for the, again, HTTPS. So the browser is going to pass that to the key. The key is going to be, oh, let me see. OK, I do have an identity registered for login to Microsoft Online or Microsoft.com. And in this case, I am going to ask the end user to finish the gesture to prove that they're by the key. Right? So, OK, do the second thing, whether it's enter the PIN or whether it's touch the biometric. And so they will finish the gesture. And once the user does that, that's the way that the user consents to sign in, is they have to finish the gesture. If they don't want to sign in, they can just pull the key out and say, nope, I don't want to sign in. And so if the user completes the gesture, then at that point, we will use, again, the same private key, and we will sign, in this case, in this response, we will send nonce2 signed. And this is what Azure D will see in the response, is signed nonce2. At that point, Azure Active Directory will take that signed nonce2, compare it with the public key. Can it actually check the signature with that public key? If it does work, then this is a successful sign-in. If it doesn't work, then you signed with some other private key than the one that was supposed to be used, and you're an imposter. So this is how it works under the hood in the traditional registration or sign-in request to secure this. A point that I wanted to call out that's very important for you to internalize as an admin or an architect pitching this to your leadership or to your end users. Notice that the biometric, right, the biometric of the user, the fingerprint reader that was used to generate the private key, this never left, right, never left the user's device. That's the most important. A lot of end users, rightfully so, are conscientious about their credentials, their biometrics being scanned, put in the cloud. Oh, all these identity providers, I don't want to give them, they already know where I shop and where I go. I don't want to also give them my biometric. Rightfully so, that is a correct concern. And so the beauty of the FIDO2 was designed with that concern in mind. And so the PIN, the biometric, whatever you're doing, either in Windows Hello for Business or in a security key, never travels to Azure Active Directory. It doesn't establish anything in Azure Active Directory. And we, as Microsoft, no matter how much we want you to trust us, we're not storing your biometric in the cloud. We're not storing the private key in the cloud, which addresses the third point that I mentioned about the flaws in passwords, is I can break into, shady site.com that you signed in as a teenager, forgot about completely, and steal your passwords there, and then try to replay them against all your other sites. If someone somehow successfully breaks into Azure Active Directory's FIDO storage of accounts and credentials, there's nothing to steal. These public keys are worthless. Nobody can use them to sign anything. You need the private key that's stored on the device to finish this dance in a sign-in sequence. So this is kind of how FIDO2 works under the hood, how phishing-resistant credentials as a technology works under the hood to both secure the sign-in, prevent anything replayable from being put on the channel, and also preserve the user privacy. So what do you think, Imbar?
Tarek, this looks promising, but can you walk us through how it prevents the phishing attack that I've described earlier?
Great question. So let's actually walk through an example of a bad guy who's trying to do the earlier examples. I'm going to create a site over here, and it's going to be called, login.foo.com that looks close enough to Microsoft.com. Send a phishing email to the user, oh, click here to claim an Xbox prize or something like that. In this case, in the registration flow, I'm going to have to send a nonce. And my nonce will be nonce3. Will not be any of these nonces. And when it hits the key will not mistaken me for Microsoft because this is HTTPS. So it will immediately think this is a new registration request. It will allow me to create a new account, but it will not surrender anything from this flow. And then let's say I successfully get you to register with me, dupe you into saying, oh, go ahead, register again. We made a mistake in the first time. So you think you're registering it. And so you're entering the same PIN or biometric over here, but you're generating another private key and another public key. Now they try to play this attack against Azure Active Directory. So they try to play the blue flow, right? So they're going to request a sign-in request with Azure AD. We're going to send them nonce 4 now. And they, first of all, they can't sign it with your key because they don't have the private key. They only have the public key. So all that's in their database is the public key. They can't replay back the one that you signed, nonce 3, because it does not match the one we sent. And so they're stuck. So they cannot phish you for something with them that they can later replay back with us. And so this is how it works under the hood, and I hope this helps people understand how it's much more secure. And over to you now, Inbar.
Thanks, Tarek. I'm now going to talk about how to actually deploy phishing-resistant credentials.
Excellent.
So here at Microsoft, employees have been using passwordless authentication methods for a while. I personally don't remember my password. Can't tell you when was the last time I used it, and honestly, that feels great. Last year, we started a pilot to use only phishing-resistant authentication methods. And today, I want to share with you some of our learnings. At a high level, we have 5 phases: enable, register and use, monitor, recovery, troubleshooting, and one bonus phase. We call it password scramble. I'll get to it in a bit. Let's start with enablement. For your deployment, we recommend you to start with actually enabling FIDO2 for all the users in your tenant. We have done that in the Microsoft tenant. We allow users to just bring their devices, and we have seen an increase of usage, just organic growth of usage of FIDO2 keys, just by allowing it to users. For your pilot, though, we recommend that you choose a small set of users that represent high-value attacks in your tenant. So administrators and executives would be a great choice. Let's start with a demo of how you can enable phishing-resistant authentication methods in your tenant. So in this demo, we're going to look at how to enable FIDO2 and temporary access pass for all the users in your tenant. First step, we'll go into the security blade in Azure AD. Next, we're going to authentication methods. And here you can see both FIDO2 and temporary access under the authentication method. This is how I can enable a specific authentication method for all users or specify it for specific users and groups. The same way I can do for temporary access pass. I'll enable it for all users. And that's it. Back to the board. Okay, that was our first part, enable. Let's talk about the second phase of the deployment, registration and use. Before I dive into the drawing, I want to call out 2 things. First of all, as administrators, we have to drive the registration of the users. The reason is that unlike methods like SMS, for example, you cannot register that on behalf of the user. You actually have to get the user's gesture, as Tarek explained earlier, in order to get them registered. The second thing I'm going to call out is that I'm going to show you how it looks like with in a hybrid deployment, where you have the Azure AD federated with another IDP, such as ADFS. This is the more complex scenario. You definitely don't have or don't need hybrid configuration in order to deploy phishing-resistant credentials, but we did want to show you how it looks like in a more complex environment. So I'll start with drawing Azure AD over here. And then we will have 3 applications federated with Azure AD. I'll start with a SaaS app. We have our security info page. That's AKMS/MySecurityInfo. And finally, I'm going to have here an ID verification. We'll draw here the IDP. That's the federated IDP, and we'll have our user over here. Okay, just to set some context, let's start with how it looks like usually when a user is trying to sign into a federated application, SaaS application federated with Azure AD when they are a federated user. So the user would go to their SaaS app. The SaaS app, basically, because it's federated with Azure AD, that will redirect the user back to the federated IDP. The user authenticates here, goes back to Azure AD, gets a token to the SaaS app, and they're good to go. Okay, now let's talk about how you can get a user to register a phishing-resistant authentication method without going through this federated flow. In order to register a phishing-resistant authentication method such as FIDO2, user can use temporary access pass. It's a time-limited passcode that serves as a strong credential and allow user to get this MFA claim and register those methods. In order to get this temporary access pass, you should be thinking about identity verification processes you want to put in front of the temporary access pass in order to make sure you're issuing the temporary access pass to the right user. So we have users or customers who were able to just utilize existing onboarding processes and incorporate the tab creation into those flows. We have other customers who are building remote identity verification applications where think about a user who have to, for example, provide a government-issued ID, maybe talk to someone on the camera. But no matter what you're doing, eventually you have to verify the user's identity before you're issuing them a temporary access pass. We have some more information about this at AKMS/taponboard. Okay, so once you verify the user's identity, the user have gone through the identity process, we verify their identity. Now this application is going to make an MS Graph call to Azure AD. We're making a request to get a new temporary access pass. So let's say in return, the application is getting back a temporary access pass. Let's say it is 123 ABC. You can also specify additional limitations, such as one time and the duration of this temporary access pass. Okay, so this application is showing the temporary access pass to the user and asking them to go to the My Security Info page. As I mentioned earlier, the Security Info page is another federated application with Azure AD. So without temporary access pass, the user will be getting redirected back to their federated IDP, had to authenticate there and all of that. However, in this case, we have a valid temporary access pass. So we ask the user to authenticate using their temporary access pass. When a user have a valid access pass, we prefer that over federation. So we don't send the user back to their IDP. Okay, the user have authenticated. Now they're going into the security info page and going through and adding a new FIDO2 key, similar to the flow that Tarek just explained us. Okay, let's take a look at how the use look like. I'll use another curl for that. So now the user have a FIDO2 key register on their account, and let's say they're going into the SaaS application again. On the first time the user is going to use the FIDO key, we ask them to actually go and proactively choose to use a FIDO. The reason is that we need to know that on that specific platform, they're able and capable of using that specific authentication method. So the user is choosing to use a FIDO key. And they can sign into the SaaS application, everything is great. On the Azure AD side, once we know that the user is able to use this method on this platform or this device, we're also updating something that we called most recently used, or in short, MRU. That will be an indication for us that the user used FIDO on this application, on this platform, and the next time they try to sign in for any Azure AD federated application on that machine, we will be able to prompt them for this authentication method. Let's move on to our next part, monitor. In a the monitoring phase, you want to start keeping track of progress and sign-ins for two reasons. First of all, you want to make sure that users are actually registering FIDO2 or Windows Hello for Business, and you're able to get them adopting those authentication methods. The other thing you want to start looking at is actually making sure they're able to sign in, right? We want to make sure they're able to use those authentication methods and they don't fall back into password or their federated flow that I just showed you. So now let me take you through a quick demo of how you can monitor this. In this demo, let's take a look at how to track progress of your pilot, both from registration perspective as well as successful sign-ins. I'm in the authentication method blade and I'm going to click on activity. Under registration, you can take a look. Let's change this for the last month, for example, and see how many authentication methods were registered during the last 30 days. So you can track the progress of Fido, Windows Hello for Business, and temporary access pass. Okay, that's great. Now let's take a look at usage. So you can see here sign in by authentication methods. And as well, I can change it for the last 30 days, for example, and I can see how many sign-ins, successful sign-ins we had with FIDO2. Now let's deep dive a little bit into the users in the pilot. First of all, I want to make sure that passwords are not being used, or how much password are being used by the users in the pilot, and if they're successful with Windows Hello for Business and FIDO2. So I'm jumping into the sign-in logs. This is already filtered by my user who is part of the pilot. And I want to take a look at which authentication method the user is able to use. So if I'm choosing here one of the sign-ins, under the authentication details tab, you can see that the user was able to successfully sign in with a FIDO2 key. What's important to keep in mind is, are those users able to use the FIDO2 and Windows Hello for Business on the applications that they want you to use, and if they're using password anywhere. Okay, back to the drawing board. Okay, so now we know how to monitor the progress of our deployment. Let's go to the next part, recover. As in any multi-factor authentication deployment, strong authentication deployment, you have to think about the recovery process. How do you gain access back to the account when the user maybe just forgot their authentication device at home for today, or when they truly lost all of their authentication devices and they have to gain access back to their account? So for that, we'll go back to the drawing, and I'll use another color this time. Recovery process starts the same. We're using the identity verification process. So you can reuse the same application and do some identity verification before the user is getting a new tap, a temporary access pass. So let's say the user have gone through the verification and they got a new temporary access pass. Okay, so let's say we got here, this one is 456. And we present this to the user back. Now we have two options. If, for example, the user just lost their device, just forgot their device at home today, they can go to their SaaS application and continue working. So this time we'll go again into their SaaS application here. And because the user have a valid temporary access pass, we again prefer temporary access pass over any other authentication method. So in general, we prefer passwordless authentication method over federation, and we prefer temporary access pass over any other authentication method. So even if the user does have a FIDO key, we would prefer and prompt them to use tap. So now the user is prompted for tap. They're typing their new temporary access pass code, and they're good to go for the duration of this temporary access pass. What do you do in a case where the user really lost all of their devices? Okay, so here we have to go again to the security info page. And again, the user have a tap. We'll offer them to use a tap first. And it's important to call out that the user can always change and choose another authentication method. They can always choose sign in another way, try to switch to tap. They can also use password and get redirected back to the IDP. So there is always backup options. But in this case, I got into the security info page that tap provided me an MFA claim, and I can go ahead and remove my old FIDO key add a nuke FIDO key. And one more thing to remember is that we also have a new admin role, the authentication method admin role, who can manage the user's authentication method. In the case of phishing-resistant credentials, that will be our admin. Let me just write it. In the case of phishing-resistant authentication method, the admin can only delete the user's authentication method, because remember, we have to get the user's gesture in order to have them register the method. Okay, so that was our recovery flow. And now let's go to our next step, troubleshooting. I wanted to call out a few questions that are common and known when we're talking about strong phishing-resistant deployment. The first one is why FIDO2 is not offered to my users to use. So for this case, I recommend you go to our passwordless deployment guide at AKMS/passwordless deployment guide and look for the supported platform for FIDO. There are some nuances, so make sure you check it out. The second question that we get is why users are not getting or prompted for the authentication method that they have just registered. So if you remember, I was talking about the most recently used. We need the user to just authenticate once with this passwordless authentication method in order for us to keep prompting the user on this device with that authentication method. So just make sure that your users know that they can switch from their what they were using into this newly registered authentication method. And the last thing I want to call out is how do I securely deliver temporary access pass to my users? This is really depending on your business processes and the identity verification that you want to do in front of the temporary access pass. I recommend you go to AKMS/tap-onboard to read about how other customers are using temporary access pass and how they're using or what identity verification processes they're doing in front of it. Okay, almost done. One last thing I really want to call out. This is the password scramble. After some time, you've been using this, you're using phishing-resistant authentication method in your tenant, and you feel good about the usage. Your user doesn't need a password. It's time to say goodbye to the password. We call it password scramble. It is changing the user's password to something unknown to them, so they cannot be phished into using that. A few things that I want to call out here. First of all, if you have been piloting with administrators, which are cloud-only, which can be, and hopefully they are, cloud-only account, it's easier to just change their password because you know that all the applications that they're using are already federated, cloud-federated applications. If the users you have been testing with are sourced on-prem, they may have some applications that still require them to use a password. So make sure you're looking into the password usage of those users. This is kind of going back into the monitoring part, making sure users are not using password. Two tips and learnings from our side here as well is that keep in mind that you want to do a password change, not a password reset. If the user have a password reset or you're resetting the user's password, they have a pending password change, and some applications may not like it and prevent them from accessing the application. The second one I just want you to be aware of is that when you do this password change, sessions that were established with a password will be revoked, and sessions that were established with passwordless credentials will remain active. That's it for our deployment part. So now let's just finish up with some go-tos. The first one is, if you haven't started your multifactor authentication deployment yet, consider starting it with passwordless authentication method and phishing-resistant authentication method. The second one is learn why phishing-resistant is so important, why it's more secure and better for the user's privacy. And the third one, if you do have an MFA deployment, first of all, that's great. Consider how you start moving some of your users, the high-value attacks, into those phishing-resistant authentication method. Okay, that's it for today. I know we covered a lot, so if you need to read more, we have more information in the session notes. Thank you for joining us today and have a great day.